We looked for another solution and say no, we need to have a simple pin registration, which is easy to mount, easy to set up, and which gives a good repeatability. And when it's easy, and then it doesn't cost a lot, so it reduces the price. We have a third sensor in the oven that can measure the actual temperature of the board. And this third sensor is also linked to the controller. Simple PCB fixation, easy, you just put it in on some supports. And automatic opening of the drawer. We are using 3000 watts, not 15,000 or 18,000, that is already a difference. We cannot work with different temperature zones on which we have sufficient power in every zone. No, we have to heat up the whole system, and the whole system needs to go through the same flow. Cooling down under the solid temperature is another issue in a chamber oven. You cannot expect a chamber oven to cool down boom immediately, because you cannot open the drawer at, let's say, 225 degrees, because then your components will fly off. So you need to go under your melting point first, and then open the drawer, and then cool down quickly. But this first cooling down phase is of course a lot slower than in a throughput oven.
When you only heat from the top side with a hot air or something, or with infrared or with laser or whatever, you probably will damage the board. If you heat up your product just because you like it 5 times, your product will be 2.5 years older than you make it from the first start, right? That's really important. So people who are thinking, I'm soldering, it doesn't shine that well, I solder again, it's half a year. Solder again, it's a year. It's a half a kilo, but there's only 150 grams in it. So the jar is for a half a kilo, so that's a standard jar. But what's inside, it's only for 150 grams. Mainly to do your sets of prototypes. So you don't have to throw away the other 350 grams. These are actually lint-free, Sontora. Sontora is a brand name of Dupont, a big manufacturer of wipes. These are actually the same wipes which are also used in big production facilities. If you have a screen printer automated with wipe rolls and everything, this is actually the same material, so it doesn't leave any lint residue on your screen printer. Because one piece of lint on a QFP will give you a bad solder code. What we need to do in the beginning to fresh up the paste, and we do that every day if we need the paste, we're just going to do the cooking again, so mixing.
Positioning of the magnetic blocks. As I explained, the 3mm pin is for the PCB, 5mm pins for the stencil. You can fix it. You have some more pins for support the PCB, so maybe if you have a panel and it is routed by pins or so, that it is more stable. The frame, you take the stencil, fit the stencil into the clamping, and then you look through the 5mm hole from the magnetic blocks, and that's the way how it is registered. So I will clamp it now, bring tension on the frame, and I think everybody can look.
It's just
with it exactly, it's not exactly. Yeah. I mean, this is the way. You make your paste on the stencil, it's a squeegee, you squeegee it. We have 2 magnetics to fix the squeegee. Now it is important, bring the table down, that is very important. You can take the next PCB, fix it, take it, bring up the table, and the next one.
So it's really important to just have a good, easily snap to see if the paste is there, that it's all good, and then you start to assemble. If you don't do this right, and we can do that later on, you just wipe it off with the stencil wipe, you dry it with the wipe, and you do it again. If I do a BGA and I throw it on it, it can be good, it can be bad. Process-wise, not our idea of doing a prototype or production. Mostly if people are coming to us and they have one BGA and one board, designers just say this has to match and it has to work. So from the first shot right.